Hello students, welcome back to my channel Explore Physics, Let's Explore. In the previous class, I've explained you about the structure of human eye, its different parts and their functions. Today we are going to talk a little more about the human eye and the defects of vision. If you remember, yesterday I've explained you about the ability of the human lens to change its focal length. When we have to see the objects which are at far off distances, the ciliary muscles are relaxed and our eye lens becomes thin, and that increases its focal length. If we have to see the nearby objects, our ciliary muscles are strained, that makes the eye lens little thick and the focal length decreases. So this ability of the eye lens to change its focal length is called power of accommodation. So power of accommodation is the ability of the eye lens to change its focal length depending upon the object it has to see. Maximum distance a normal human eye can see is infinity. So it is also called the far point. So the far point for a normal human eye is infinity. Without too much relaxing or too much straining our ciliary muscle, we can see the objects which are at infinity distinctly. So this is called the far point of the human eye. What is the near point? What is the near point? Near point is the point where the human eye can see the objects which are closer. What is that particular distance? It is 25 centimeter. This is the near point of a normal human eye, that is 25 centimeter. This is also called the distance or least distance of distinct vision. Distinct vision. So if a book is held at that place, say at 25 centimeter, then in that case, without exerting our ciliary muscles, one can easily see. So that's why it's called least distance of distinct vision. It is also called the near point of the human eye. So it means our human eye can see the objects or from 25 centimeter to infinity. So these two are the points, which is the near point and the far point. Through this, between this infinity and the near point, the human eye can see the object without exerting the ciliary muscles. A person who is not able to see beyond 25 or not able to see the objects which are at infinity or at a little more distance, then we'll say that the eye has some defects. What are the defects? We are going to see that. What are these defects? One is myopia or short-sightedness. What does it mean? It means that the person who are suffering with myopia or short-sightedness, they can see the objects which are at the shorter distances or close by, but unable to see the objects which are at a distant position. So they are able to see the objects which are at the close distance. What are the causes for this? One, excessive curvature of the eye lens, or the second cause is elongation of eyeball. So excessive curvature of eye lens means the focal length of the lens becomes little shorter, And the elongation of eyeball means the eyeball becomes little big or little long. Yeah, it becomes little big. So what happens because of these two causes? The image, instead of being formed at retina, forms a little before that. So instead of the image falling on retina, it falls somewhere in between the eye. So we have to bring that, how the correction is done, we have to bring that image to the retina. So I'll show you first the eye lens, which has, so for them the far point, instead of infinity, it becomes little closer or it becomes little shorter. It's before infinity. So the rays which are coming parallel, they form the image before the retina, not at retina. For the persons who are suffering from this defect, the far point is before the infinity. So if I'm going to consider it here, so for them it is before infinity, and then the image is formed. So what is the correction which has to be done? So this is the far point which is it at infinity. It becomes, I'm going to take F for far point. So this is the far point for myopic eye. Instead of being at infinity, it becomes closer, nearer. So how it is to be corrected? The myopic eye correction is to be done by a lens which takes the image or brings the image to the retina. So if we have these rays which were coming parallel and forming the image before, and here we have the myopic, the near far point or the myopic eye, the correction has to be done by placing the concave lens of appropriate focal length, so that a virtual image is, by using this, a virtual image is formed at the far point, the myopic eye far point, so that it brings the image to the retina. So there the image is formed, and this is the correction. This is the correction of the myopic eye, that a concave lens of appropriate focal length is placed before the, or is used for the specs, so that it makes the virtual image at the myopic eye far point, and this is going to make the real inverted image at retina. So that is how the correction for myopic eye is to be done. One, the causes you should know, because of excessive curvature of eyeball lens and the elongation of the eyeball. These are two cases. This is the correction, and how it happened, because the far point, instead of being at infinity, becomes a little closer, nearer, and then the correction is done by putting or by using the specs of appropriate powers concave lens, so that the image is now formed at retina. So this is all about the myopic or the myopia, short-sightedness, the defects of the defect of vision. The second defect is hypermetropia or long-sightedness. And what is that? It's called hypermetropia or long-sightedness. Long-sightedness, where the person can see the object at distant position, but is not able to see the object which are close by. So this is hypermetropia. You can see the objects which are at distant positions. What are the causes? Just opposite to the myopia. There it was excessive curvature. Here the focal length is more. And two, the second is the eyeball is small or short. So the focal length has become little more as compared to the normal eye, and eyeball is small. So what happens in this case, in this defect, the image, instead of being formed at retina, it is formed beyond retina. So for in this case, the near point of the defective eye is beyond 25 centimeter. So he, instead of looking at the book or anything which is going to see at 25 centimeter, he has to place the book or any object beyond 25 centimeter. Then he is only able to see the object clearly. So the the near point goes beyond 25 centimeter, and the causes are these. Now we have to bring back the image at retina, which was formed beyond retina. So the correction is to be done by using a convex lens of appropriate power. So I'll explain you again with the diagram. So we have say this is our eye lens. So if this is the far point, see this was 25 centimeter, I'm showing it as N. It is now N dash for the myopic eye. So here the image is formed at retina. So he has to, if it's at near point, then it becomes beyond retina. If it's placed at 25 centimeter, the image is formed here. So if this is N, at N dash he is comfortably seeing on the, it's falling at retina, but at N the image is formed like this. So the correction is to be done because we have to bring back, we have to converge it before that. So for the correction of a hypermetropic eye, a convex lens of appropriate power is used so that now the image is formed at retina. So I have explained you what is hypermetropia. The person can see the object at distant positions but not able to see the objects which are nearby. The reason is that the near point goes beyond 25 centimeter, and when the object is placed at 25 centimeter, the image is formed beyond retina after that. So we have to bring that image back to retina. For that matter, a suitable power convex lens is being used so that it makes the image at retina. So this is the second defects of vision, hypermetropia or long-sightedness. So now the third defect is presbyopia. It's also called special hypermetropia. This is especially for the aging persons. When the person ages, the ciliary muscles become less flexible or become rigid. So because of that, the person can't see the objects which are at nearby and still is able to see the object which are at distant positions. So that's why it's called hypermetropia. Now this is because of aging, as I told you, and it may happen that the person can suffer from myopia as well as from hypermetropia. So the correction can, for this case, when it is simple presbyopia, when the person can't see the object which are close by, you must have seen the aged person, seeing the book a little at far off distance, so they can't see the object which are close by. So this is the presbyopia. For a person who suffers from both hypermyopia and metropia as he ages or as she ages, then what happens? They have to use the bifocal lenses. And what is that? Bifocal lenses where the lower part is made up of, it has the two lenses, concave and convex lens are merged together. The lower part is convex lens, the lower part of the specs I am talking about. So the lower part is the convex lens. You must have seen the lower part is convex lens, which helps the person to see, which helps the person to read the book and all. And the upper part is concave lens. So this is convex, and these two are the concave lenses. So the lower part helps them to see or to read the book and all, and the upper part, concave lenses, help them to see the objects at distant position. So this is for the persons who suffer from both myopia and hypermetropia. As I told you, for this case, bifocal lenses are used, and the reason is weakening of ciliary muscles, or they become less flexible or become rigid. The fourth is cataract. What happens in cataract? The eyelens becomes cloudy or milky, and it may lead to partial or full loss of vision. Now, it cannot be corrected, or it cannot be rectified by using lenses. So, surgical intervention or surgical procedure is to be adopted for that matter, where the cataract, in fact, affected lens is replaced by the artificial lenses. So, for this only the surgical interventions or procedures are needed. So, this is all about the defects of vision. I've told you about the myopia, hypermetropia, presbyopia, and cataract. That is all for the day today. Have a healthy and safe day. Thank you.